Okay, guys, so we have most of the teardrop bushing cammed out. Alright, so what we have left, we have this snap ring groove, and we got this tapped hole, right? Okay, so let's look at our tool list here. So our tool list, we got tool 5, we got 62 thousandths wide groove tool. Tool 6, we have a 1/4 center drill. I don't really know if that's 1/4 inch OD. I think it's actually 5/16, but it doesn't matter because all we're doing is just drilling like a little pilot hole. And then we have a 21/32 drill for the tapped hole for the 3/4 tin, and we get the tap. Okay, so let's go ahead and create these tools. So we got 62 thousandths wide groove tool, right? Alright, so we're going to use a 2D contour to do that. Now this groove's 100 thousandths wide, so we're going to do this a little bit different. So what I'm going to do is I'm going to go to 2D contour, go create a new tool, and let's put 0.062 groove tool, cutter. Now we're not actually using a T-slot mill, but the spun profile will be something similar to a slot mill. So we're just gonna go with this. Diameter. Ooh, I did not get that. Let's say it's a 1/2 inch. I really don't know what it is. 62 thousandths wide. Okay, so now look at the rendering of my tool. See how it looks weird? There's a few problems with this. One, the shaft diameter. Let's change that. Let's make that. Let's make it 0.25. And this corner radius right here. Let's just make this 0. There's probably like a 2 thousandths radius on the insert, but I mean it's so small it doesn't even matter. We'll just put 0. Okay, feed rate. Let's see. I'm gonna go 1500, and I'm gonna go 10 inches a minute because it's just like a single point groove tool. And my plunge, I'm gonna go 30 because it's not actually cutting at the plunge; it's getting in position. Post processor, tool number 5. Let's check out our tool list. Tool number 5. Yep, 62 thousandths groove tool. And let's hit OK. Alright, so the way this is going to work is we're going to select this geometry right here. And what we're going to do is on the bottom height, we're going to put it on selection, and we're going to select this floor right there. Alright. And let's see. Compensation, let's put it on where, and let's say OK. So I have a toolpath that looks like this. Now when we simulate this, what we're gonna have to watch out for is make sure that that tool is gonna clear. It's not gonna hit anything, and we're good right there. You see it overlapping right there? That's the bottom of the part, so that doesn't matter. That's like way down here. Okay, so I'm gonna kind of single step it down a couple of times, and we're in position right there, just making sure we're not gonna crash it. We want to feed into the material, not just dive into it or crash into it. Alright, so I'm gonna hit play, and it looks like something like this, and watch it when it exits. Alright, see how the tool turned red? Let's see why it turned red. So I'm going to go back a little bit. Let's put it in top view. I want to see if it's actually colliding. Okay, so it comes out, and I'm trying to see where it turned red. Right here is where it turns red. Why does it turn red right we're actually good. I don't know what Fusion's complaining about right there. If anybody sees something that I don't, leave it in the comment and I'll check it out. But that looks good. I don't know. It's just trying to bring it to our attention. That's why it's turning red. Collision detection. Just because the tool turns red, it's triggering the collision detection, doesn't mean that you're colliding. It means that you should check it out. But yeah, we're good right there. Okay, so that's that toolpath. I'm gonna go ahead and name this Groove Tool 1. Okay. Now, this is the thing. So this is the way I do it. I mean, you could do this a couple of different routes. What I'm going to do is, okay, so this is the thing. The tool is 62 thousandths wide, right? But the groove is 100 thousandths wide. So we still have 38 thousandths left to cut. Right? So the groove isn't to size. So what we're going to do is I'm actually going to duplicate this this groove toolpath. Rename this one 2. Okay. So we still have 38 thousandths on our height to remove, right? So what I'm going to do is the second duplicated groove tool, I'm going to go to my hive and I'm going to offset this up 0.038. Alright, so it should look something like this. It's kind of hard to tell. So we're going to do, let's simulate both of these. Let's see. And you can see if these are at 2 different heights right here. So it comes up and goes back through. Looks good. Looks pretty good. Perfect. Okay. Go ahead and hit save. Make sure you hit save all the time. If you don't hit save, one day you'll regret it. Probably going to be in the near future. Okay, so we have a groove. Now all we have to do is we have to center drill, and tap this thread. Okay, so let's look at my list right here. So tool 6 is going to be a 1/4 inch center drill, and you know what? I'm going to rename that. I'm pretty sure it's supposed to be a 5/16. I think standard center drill diameter is 5/16. I don't know. They go, to be honest, I just drill pilot holes. I don't usually use a center drill the way it was designed to be used. Probably not a good thing. But that's how I machine. And it's working out pretty good for me. Okay, so tool 6, center drill. So I'm gonna go over here, go to drill, go to select the tool, let's make a new tool. Let's name this center drill. Center drill, tip diameter, You know, none of this really matters. We're just gonna make a little pilot hole. Not really too worried about it. Let's see, spindle speed. Go 1200 RPM. Cutting feed rate. Let's go 4 inches a minute. Tool number, tool 6. The rendering isn't really, my settings aren't really right. It's not supposed to be tapered like that, but it's just a center drill. It doesn't matter. I'm literally drilling a little bitty dimple into the part, right? Alright, so okay. And now sometimes you have to look out, depending on the latest Fusion 360 update. Sometimes it will want to drill it off center, so just be aware. I've seen that happen. Okay, so we're just center drilling, right? So all we need to do is cut like a little bitty pilot hole in the material. So what I'm gonna do is on the bottom height, we're just gonna put this on origin, absolute, and I'm gonna go minus 0.1, and it'll have something that looks like this, right? Drilling, wrap it out, it's good. Looks good. Let's hit save. I'm gonna name this center drill. Okay, let's go back to drill. I'm going to do the same thing, except this time we're going to use the 21/32 drill because that's our pre-drill size for the 3/4 tin tap. So go make a tool. I don't feel like calculating the decimal equivalent, so I'm just going to enter the fraction because that will totally work. Make sure we put this on drill. Speeds and feeds. Let's see. Go to 900. 4 inches a minute sounds good. Looks good. Okay, so remember our stock was 1 inch thick, right? We faced off 30 thousandths, so we have stock. Even though the model is only 800 thousandths tall, we still want to go through the stock material, not just through the model. All right, now I'll show you what I mean. Okay, so I'm gonna do bottom height. I'm gonna put it on stock bottom, right? And now notice the body of the drill doesn't go through, right? So you would have like a big burr. I mean, the burr would be so big you can't even really call it a burr. You would pretty much have like a really small countersink. So always, I would suggest always using the drill tip. If it's a through hole, use drill tip through. Alright, so it has something like that, and I like to go extra 50 thousandths just to make sure that it goes through. And let's see, because we're tapping, you don't want to peck too much, okay? We want to peck, but we don't want to peck too much because we're cutting kind of deep, and it's carbon steel. So I'm not gonna do the partial retract. Actually, yeah, let's just do the partial retract. You don't want to overdo it on the depth right here because the drill will cut oversized, which means that your thread will be a little bit on the loose side. which could mean that it could possibly fail inspection. So that's one thing to keep in mind. So okay. So I'm going to name this 21 30-second drill. And let's go ahead and do our tap. So tool 8 is going to be a 3/4 tin UNC, right? So I'm going to go over here and go to drilling, even though it's a tap. Go to tool, let's make a new tool. Cutter, let's put it on tap right hand. Diameter 0.75. Thread pitch, I don't know what that is, but well, actually I do. What you could do is the fraction, so 1 inch divided by 10, and which is 0.1. So remember, our pitch is 10 threads per inch, right? So if there's 10 threads per inch in a 1 inch distance, the point, the tip of one thread to the other next is 100 thousandths difference. Okay, it's basically 1 inch divided by 10. So keep that in mind. Everything looks good. Feeds and speeds. Let's see. Let's go 400. I usually go slower on the RPM for tapping. And notice there's no feed rate. Why is there no feed rate? Because you don't control the feed rate. The feed rate is going to be relative to the thread pitch and RPM. Okay, so whatever the RPM it is, it's gonna configure how it has to turn and twist into the material to achieve a 0.1 thread pitch. Okay, looks good. I'm gonna hit OK. Okay, so this is what we want to do. Bottom, let's go through stock bottom, down, let's go down to extra, I'm actually going to go down to extra 100. Well, one thing is a through hole, but two, because the thread, so the geometry of a tap, basically, it's got a taper on it, right? So if you don't go extra deep, actually, you know what? Let's go 200 thousandths. You don't go extra deep, depending on whoever makes that tap and what kind of tap it is, it may not actually get to the full diameter. Okay, so drill cycle. Now remember, we selected a drilling cycle, right? But when I go over here to define like the parameters and settings of the cycle type, notice it's already on tapping. Why does it know that? How does it know that? That's because we selected a tap tool, right? And we selected a thread as the hole. Okay? There's some intelligence to Fusion 360. So let's go ahead and name this 3/4-10 tap. Looks pretty good. Let's go ahead and hit save.